right. We are going to do a little bit of review today for the exam tomorrow. So the plan is to just go through sort of an outline of the major topics that we covered for this second midterm. It is not a complete and exhaustive list, so there might be other things that I didn't put on here that may show up on the exam, but these are the big topics. Okay? And I don't know that there were any sections that would necessarily skip in any of the textbooks. I didn't notice any, so most of what we've covered, or most of what you would see in the textbook is what's going to be on the exam. So we're going to start with chapter 14, section 4, and that was where we're relating temperature and rate. We're using the Arrhenius equation. So make sure you can understand how temperature and rate are related. Be sure you can calculate the effect of temperature on rate using the Arrhenius equation, the two-point Arrhenius equation. Make sure you know which R goes in there. Something like that. We have orientation factor that shows up in the Arrhenius equation, as well as activation energy. And make sure that if you have a graph with Arrhenius information on it, you're able to interpret that. So this would look like natural log of the rate over 1 over t versus 1 over t. You would get a plot. Okay, fit the line and know what the slope, know what the slope is going to be. I don't know why I wrote that. Minus EA over R. Okay. Questions on that? In section 15, this is where we started looking at reaction mechanisms. So you're given an overall reaction, and you then saw the elementary reaction steps that make up that reaction. From those elementary reactions, we can determine rate laws. If we have a more than one step mechanism, if the first step is the slow step, determining the rate law is relatively straightforward. Rate equals K times the concentration of reactants for the slow step. If there's a fast first step that has equilibrium, then there's a little bit more algebra you have to do, so make sure you're comfortable with that. And then we're going to work on one of these today, an energy profile diagram. So this is where we have energy on Y and progress of reaction on X. Okay. And we had, something that looks like that with the reaction intermediates, transition states, and things like that. Okay. And then the last section we touched on just sort of briefly were catalysts. So number one thing is make sure you understand what a catalyst does to a reaction. Yes, it increases the rate, but how does it do that? Okay, and the way a catalyst works is that it lowers the activation energy. It may change the reaction mechanism, okay, most likely does, and thereby increases the rate somehow. Okay, so that's chapter 4. And then chapter 16, we are only going to be covering sections 1 through 4. There may have been some homework that had further sections, so I apologize for that. Don't need to do those. You can do them later if you've come across those questions. I don't think there's a late penalty, right? So anyway, 3 definitions for the acids and bases: Arrhenius, Bronsted, Lowry, and Lewis. Make sure you can identify those. Conjugate acid-base pairs. Okay, so be able to recognize the acid form, the base form. Okay, and then the strength of the pairs. This is sort of very general speaking. We've had that chart that had the up arrow and the down arrow showing the range of pH. You don't need to memorize that table, but you should be familiar with how to use that. Okay, and know that if you have a strong acid that completely dissociates, the products that you're going to get are going to be negligible bases, and if you have a strong base that dissociates completely in water, you're going to have negligible acids on the product side. Okay. We then spent a lot of time talking about the autoionization of water. So this is where water produces H plus and OH minus in small concentrations. We came up with an equilibrium constant expression for the autoionization of water. Kw equals concentration of H plus times OH minus.
For the conjugate acid-base pairs, is that
Mhm.
in terms of Arrhenius, Bronsted, Lowry, or Lewis?
So for conjugate acid-base pairs, what definition should we follow? Mostly, we're going to be concerned with Arrhenius and Bronsted-Lowry. If you look at that table of acids and bases with their relative strengths, I don't think, well, they all follow the Lewis acid-base definition, but none of them are only Lewis acid bases, if you know what I mean. So we don't really have the metals involved. Yeah. Okay, so then with our Kw, we have a value that we have at 25 degrees Celsius. We talked about how to calculate H plus and OH minus concentrations if we're not at 25 degrees Celsius. I think there's a problem on one of the practice exams about that. And then we looked at the pH scale, understanding the definitions of acid, base, and neutral. And then we looked at the relationships with OH minus concentrations, POH, H plus concentrations, pH, and all of that. Okay, and all of that gets related through the Kw. All right. Other questions? Yes.
So identify Lewis acid and base.
Lewis acid and base. Will it be on the exam? Is that what you said? Yeah, so there could be some Lewis acids and bases on the exam.
Are we going to get an equation sheet like last exam?
Yes, there is an equation sheet, and I believe it is posted on the midterm 2 module, which is on the left. Other things, yes.
Will we be asked to identify the strength of specific acid or base?
Will you be asked to identify the strength of specific acids and bases? I know there's a question on the practice exam like that, and I think that's beyond where we're going to be. But take a look at that. Someone else mentioned the 2-point Arrhenius equation. And there might have been what seems like a discrepancy in the actual equation. Nope. All right. Where we have, let me write out the one I have in my notes first. In my notes I have ln of K1 over K2 equals EA over R times 1 over T2 minus 1 over T1. Okay. I think this is the one that is on the equation sheet, but you can actually invert these. So you could have ln of k2 over k1, and then t1 minus t2. So I think one of the practice exams has a different equation. Am I right on that? Yeah. So I think the other one would be ln of k2 over k1 equals EA over R times 1 over T1 minus 1 over T2. So what I'm recommending is take a look at the equation sheet, practice a two-point Arrhenius equation with that equation just to make sure you have the right one, you know what goes where. It is the correct equation. Both of these are equivalent. Unless I forgot that. I think that's right. Okay. Other thing. Yes?